Alrighty, so now you're going to put all your information about how to count the number of protons, neutrons, and electrons into actually creating a model for what an atom looks like. Okay, so I'm going to transfer from the slides and write on the Go formative so that you guys can know how to use the tools when you do it on your own. Okay, so let's go here and go to our Go formative. So you go right down here, you're going to practice drawing a Bohr model for an atom of boron and fluorine using the shapes function. All right, so there's a couple of rules you need to remember. First, you need to count the number of protons from the atomic number, neutrons, which is atomic mass, minus atomic number, and electrons, same as an atomic number for neutral atoms. Right? That was everything we did from the previous video. So let's do that first for boron. So let me put boron here real quick. All right, we got boron, and you got fluorine over here. Okay, so first let's count the number of protons, neutrons, and electrons. So boron, we got to go to our periodic table. So let's go back to this periodic table that's attached right there. And look at boron, 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 boron. Boron is in period 1, group 13 or 3A. So that is that right here. And you can press this little zoom button to see closer and scroll around to see kind of how I can find the mass number or atomic mass and atomic number. Okay, so its atomic number right here is 5. So that means that P, whoops, let's write that like that. P is equal to 5, right? 5 protons. And I also know that there are 5 electrons because we're just looking at a neutral atom boron. Okay, how do I find the neutrons? All right, I have to use the atomic mass right here, which is 10.811. I'll round that up to 11, and I'll subtract that. I'll subtract this atomic mass from the atomic number, which is 5. So 11 minus 5 is equal to 6. Okay, so that is my number of neutrons. And I'll quickly transfer that onto the Go formative right here. Right, so use this text box function to make it neater. And let's use a different color. Let's use blue. And then I'm going to say P is equal to 5, electrons is equal to 5, and then I would say neutrons is equal to, what was it? 11 minus 5 is equal to 6. Okay, so I'll just write that so it's easy to remember. Okay, so now that's what we did for the first step. Now the second step, we're going to draw the nucleus, and we're just going to put the number of protons and neutrons just so that it saves time, because what I care more about is actually the electrons, and we'll explain later why. So use the circle, the shape function right here. You're going to press circle and make sure it's an open circle, so you're not going to fill in the shape. And let's make the nucleus what? Let's make it orange, or yeah, or let's do purple. All right, so I'm going to draw a circle like that. Let's put it down here. All right, and then I am just going to use my text box once again. I'm going to say P is, okay, so for P protons, there are 5 protons, and then for neutrons, there are 6 neutrons. All right, usually I would draw the particles on paper, but it's kind of hard to draw using Go formative. So now you're going to draw the electron shells for step 3. So let's use a different color so it's easy to look at. Let's use pink. All right, so for these two ones, I need you to draw 2 shells. Okay, so let's use the shape function using a circle, and this is shell number 1, and do one more, shell number 2. All right, so there's a couple rules you need to do when you put in your electrons that you see right here. So this is kind of the special step when you are writing for the number of electrons. you need to start from the closest shell first and then move outwards, right? So the first shell can only hold 2 electrons, okay? Oh, my Go form is being really buggy. Eh. Okay, so first, oh gosh, okay, let me go back. All right, that's better. First shell can only hold 2 electrons, all right? But all the other outer shells after the first one can hold up to 8 per shell, okay? Oh my gosh, it's being buggy again. Okay, so after the first shell and the outer shells, you can hold up to 8 electrons per shell. Okay, so what you're going to do is you're just going to use a filled circle to fill in the shells right here. And let's use a circle, and this time you're going to use still the pink color, and you're going to press fill shapes to make it a closed circle. Okay, so the first shell can only hold 2 electrons. So I'm going to put 1, 2, but I need to go up to 5 electrons. So once I'm done filling up the first shell that only has 2, I need to keep on counting until I have 5 total electrons. So I have 1, 2, and you notice right here, just before I move on, that they're far apart because like charges, right? 2 negative charges, like on a magnet, they repel against each other, right? Positive and negatives, they attract. Negative, negative, they repel. Or positive and positive, they repel. Okay, so you kind of want to draw them far apart. So, once again, 1, 2, and then you're going to draw it up to 5. 3, and then 4, and then 5, like that. Okay, and that's my Bohr diagram of boron. That's what it looks like. Okay, we got 5 total electrons and 3 on the outermost shell, which is going to be important for the next lesson. Whew. All right, so now let's look at fluorine. Okay, let's count the number of protons, neutrons, and electrons by going back to our periodic table. So if we look to the side, let me clear this out. Move this over. And here's fluorine right here. So we're going to look at the atomic number, which is on the top, right there. So which is 9. So it has 9 protons. Yeah, just use a text box. Let's do that. Right, there you go. P is equal to 9. And then now I also know that that's the same number as my electron. So let me draw a text box right here. Okay, so you know E is equal also to 9. But now how do I find the number of neutrons? I need to do the atomic mass right here subtracted by the atomic number. So it's 18.998. I'm going to round that number up to 19. So if I put my text box back here, I will get 19 minus 9 is going to be equal to 10. So I have 10 total neutrons. So let me transfer that over to the go formative and use the text box function here. So fluorine has P is equal to 7. E is also equal to, no, it wasn't not 7, it was 9. 9, right? Yeah, it was 9. Sorry. So it was equal to 9. And also equal to 9. And the number of neutrons is equal to 10. Alright, so now let's do the second step. In the nucleus, we're going to put the number of protons and neutrons. So let's put that, let's use a different color, right? Let's use blue. We're going to do a not a filled shape. We use a circle. So let's press this. Circle, woohoo! Alright, and then text box, I'm going to write the number of protons is equal to 9, and then the number of neutrons is equal to 10. Alright, now I'm going to draw my electron shells. So let's use green this time. Alright, and I'm just going to draw 2 shells. Okay, 2 shells on the outside of the nucleus, so that's 1, and then I got 2. Alright, and then now I'm going to write in my electrons. So I'm going to move this down a little bit so I can get the full circle. So go on here again and put fill shape. And I'm going to start from the closest shell and then move outwards. So remember, the first shell can only hold 2 electrons. So let's do circle, shape, and we do 1, 2. Remember, they're far apart because negative charges repel. And we do 3, 4, 5, 6. Okay, see how kind of they're far apart as possible. But then after 6, you have to go all the way up to 9. So to make it easier to count, I like to, although this is not conceptually correct, you pair them up next to each other so it's easier to count. So we have 1, 2, 3, 4, 5, 6, and then 7, 8, 9, like a pair like that, okay? So if you want to quickly glance to make sure you have the correct number of electrons, you could just quickly count 2, 4, 6, and then 7, 8, 9. All right. So conceptually, you want the electrons as far apart as possible, but for the sake of the model and checking your work, just have them together in pairs like that. Okay, and it helps you count that number of electrons. And that's my fluorine atom. Okay, so practice drawing that on your own.